All right, now it wants us to re-represent the data from the last homework. I'm going to keep what I think is my colors from last time. Box 1 is blue, box 2 is green, and it wants us to do this like momentum impulse bar charts. So hopefully keeping my units somewhat constant. Both of my objects had initial momentums of 0. I had the 1m box, we'll call that blue, and the 2m box, calling that green. You can see that I have like different widths because their masses was m and 2m. So this is my 2m, this is my m. But I didn't go up at all because they didn't have any initial velocity. Then we applied some force to the boxes, and I'm just going to be very generous with my force things. Let's go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to call all the way up here my 3F mark. And I'm going to go over a generous 4 as well. 2, 3, 4. We'll say that that's how long it was. So it was definitely 3F worth of force for some unknown amount of time. But there's that graph there. By comparison, the other one only had a 1, 2, 3, 4, only had this much force applied to it. F over that same period of time. And if I extended the box over, time would be bigger, but the forces would be exactly the same, kind of similar to the graph in the last one. Then finally, it wants the box's final momentum. Well, box 1 has a across of 4, which means but it needs to have the same total area as like this one plus that one. So I'm going to end up going all the way up to the top. It's 48 units. So it's ending up with some kind of velocity. We won't assign a velocity yet, but we definitely know it's m units over. Then the other one is going over 2m units. So there's my 2m. And it has an area of 4 times 4, so 16 boxes. 1 box is enough for me, though, just for the record. I'm a 1 box kind of guy. But I need to, in this case, go up 2, because that right there is still 16 boxes, but spread out over the 2 masses. So basically the idea is we applied impulse to both of these, but where the impulse went was different for the 2 objects, because one of them had a smaller mass, so most of the momentum went to speed, whereas the other one had more mass, so some of the momentum went to mass, so it ended up with less speed. It also didn't get pushed as hard, but there you go. So if I was doing this by units, if we called this one V, then this one would be 1, 2, 3, 4, 5, 6. 6 times the velocity. Okay, I don't think that's actually part of the question, but it was worth, I don't know, maybe worth doing. Maybe it helped make something make sense for somebody. Then, is the work done on the first box while speeding up greater than, less than, or the same as the work done on the second box? Well, I would say the work on box 1 was greater than the work on box 2. And my rationale is that work is equal to force times distance. I know that the force was greater. And given the same amount of time, it would have traveled a longer distance because it was going faster. We proved that on the graph. So this was also bigger. So we definitely ended up with way more work being done on object 1 than on object 2. There you go. Is the impulse given to the first box greater than, less than, or the same? Again, it's greater. But this one, you can just look at the graph. The graph shows that we had way more impulse done on the box 1 than on box 2 because it had more force done over the same period of time. So there you go. That's all I was looking for. Hopefully this all helped you out. That one was a little longer, but totally doable.